Whether it's bullets from a gun, a football going towards the goal, a squirrel jumping from tree to tree, or a monkey trying to escape a hunter, projectile motion is all around us. And what we're going to look at in these lesson videos is how to break down a problem so that we can find out what is happening, where the object is travelling to, and predict whether the ball is going to hit the bar and bounce to safety, or if it's going to be another goal. Starting with the basics, let's make sure we understand what we mean by projectile motion. A projectile is simply an object flying through the air. Away from physics, people would only be thinking about missiles really, but within physics it could be any object. Within A-level physics, we're going to simplify further and say that a projectile is an object that is travelling through space with only the force due to gravity acting upon it. Notice, I didn't say air because we're going to ignore air resistance even. Only one force, the force due to gravity acting down. This ball is not a projectile. It is resting on the ground. It's still not a projectile, it is being kicked. It's off the ground now. It is still not a projectile, it's being kicked. Here it's off the ground now, but it's still not a projectile because it is touching the foot, and the foot is still exerting a force upon it. Only now is it a projectile, as it is not touching anything. So the foot is not exerting a force on it anymore. So the only force is the weight acting down. The ball continues to move forward, not because there is any force moving it forward, but because the kick at the start provided an accelerating force. Now it just keeps going at the same speed, horizontally anyway. Okay, so we're thinking about Newton's laws here. It's going to continue on the same path unless a force acts upon it. You might need to review that section. It's a common place for people to go wrong, and that's the start of problems in this topic. So really try to make sure you understand that part. So, a typical problem starts off like the ball kicking example. But we start only when the ball has left the foot. That's time t equals 0. The ball is moving and only one force acts on it. Here's what it looks like at the start. I've got x and y axes and an arrow to represent the initial velocity of the ball, and some angle theta between the direction of motion and the horizontal. The quantities I want to monitor are s, the displacement, u, the initial velocity, v, the current velocity, a, the acceleration, and t, the time taken. We're going to split this problem in two. I could, of course, choose anything as my axes, but since g always acts down, let's have a horizontal and a vertical axis. Filling in my table, I know nothing. Alright, so there will be sx and sy, the displacements to the right and upwards, ux and uy, vx and vy, 0 and minus g. Okay, I've decided I'm going upwards. These are always like this in A level, since there's only one force and it acts down. Since I define y as being positive going upwards, the acceleration in the y direction is minus g, minus 9.81 meters per second squared. There are no other forces, so the horizontal acceleration is 0. Alright, hold on. That means that, look at Vx. What can we say about Vx? Well, since the horizontal acceleration is 0, Vx equals ux. So let me change that. The last one is t. Since time works for both directions, I don't need to write tx and ty. So, using the SUVAT system, we have 10 variables, but we know 2 of them, the accelerations. We know that tx and ty are the same. And we know that ux equals vx. So there's only 6 unknowns and 4 knowns, which is not a bad ratio. I did forget the angle theta in there though. But that actually makes life a little bit easier, and it's what we're going to use to solve these problems. We know a bit about vector components now. So ux equals u cos theta, and that's equal to vx, remember. uy equals u sine theta, and vy equals v sine theta. Still 6 variables, but they're not too tough to measure, and with theta and t bridging the horizontal and vertical equations, it works out well. It's also worth noting down that the maximum height is going to happen when Vy equals 0. So you can use that equation V equals U plus AT, rewritten as 0 equals U minus GT, or U equals GT, to find that out quite simply. Also, the range is the furthest point until the object hits the ground. The motion will be symmetrical about the position of max height, which can help, but be careful if the final height is not the same as the initial height. So to succeed with projectiles, you really need to make sure that you practice vectors first and get confident with those. Then to solve these problems, I'm going to ask you to do a SUVAT table. I'm going to ask you to do that every time. I'm going to draw a SUVAT table when I solve the problems because I know that it helps me to lay out the problem and to solve even more challenging questions with a little bit of simplicity in there. So, draw a table.